Good morning, dear students. My name is Ferhan Mazher, and today is 15th October 2021. And right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve an ATP paper. We call it the paper 4, and this paper which we have selected is May-June 2019 4-2 paper. This paper belongs from the zone 2, and the time allowed for this paper is 1 hour. So let's start today's paper, and the first thing coming up on your way is, so this is May-June 2019, 4-2 paper, 1 hour is allowed, alternative to practical. So the first question coming up on your screen is, a student determines an approximate value for the specific heat capacity of water by an electric method. The specific heat capacity of a substance is the amount of thermal energy needed to raise the temperature of 1 gram of substance by 1 degree centigrade. He sets up the apparatus as shown in the figure 1.1. So you can see here we have a glass beaker, we have water in it, we have a electric heater here. The electric heater is connected through ammeter to a power supply. Here we have a switch. He pours, he pours a mass m of water into a beaker where m is equal to 100 gram. He places a heater into the water in the beaker. He connects a voltmeter to measure the potential difference across the heater. Draw a voltmeter symbol on the circuit diagram of the figure 1.1 to show the voltmeter measuring the potential difference across the heater. So let me show you that how this is done, and let me show you here. So this is how you will show your voltmeter. You can see that the voltmeter is connected parallel to the heater. So this is how you will show it. So the next question is, then he says, the student measures the initial temperature of the water and he records it at time t equals to 0 in the table 1.1. So you can see here we have a table. In the first column, we have the time, which is in seconds, and then we have the temperature, which is in degrees centigrade. So he closes the switch, starts a stopwatch, and records the temperature theta of the water every 60 seconds for 6 minutes. He records the current I in the heater and the potential difference V across the heater. His measurements are, the current I is 4 ampere and the voltage V is 14.8 volt. The reading of the thermometer at the time t equals to 240 seconds is shown in the figure 1.2. So you can see here the reading will be 41.5. So this reading will be 41.5. Read the thermometer and record the temperature in the table 1.1. So here you will write 41.5. Let me show you. I have done this. And so here we go. So I have recorded this reading. So this reading you can see is 41.5. I read this reading from this diagram. So the next question will be, here we go. Question number B, and its first part is, this is question number, yeah. It says, state why it is important to ensure that the heating coil is completely immersed in the water. You know that that heater should be completely immersed in the water so that all the heat which is produced by the heater is absorbed by the water. So that's why it's very important. And let me show you my answer. So here we go. So we have statewide it is important to ensure that the heating coil is completely immersed in the water so that all the thermal energy is given to the water from the electric heater. Second part is, he says, state why it is important to stir the water before recording each temperature. so that all the water is at the same temperature. We stir it because so that the heat is uniform throughout the water, the temperature has uniform temperature throughout the body of the water. So the next question is, so we are done with this. On the grid in the figure 1.3, plot the graph of theta in degree centigrades on the y-axis and against t in seconds in the x-axis. Start the temperature axis at 20 degrees centigrade. Draw the smooth curve of the best fit. So we have to draw the smooth curve of the best fit. This is the figure 1.3, and I can show you that it's a very. Then he says, use your graph to calculate the temperature rise delta theta of the water in the first 200 seconds of the heating. So let me show you my answers. Okay. Okay. So here you can see I have the temperature is, if you look at the table 1.1, the time is, if I can show you the table, yeah. The time is changing from 0 to 360 and the temperature is changing from 21.5 to 48.5. So here 0, 50, 100, 150, 200, 250, 300, 350, 400. So that's the time in seconds on the x-axis. On the y-axis, I have temperature, and that temperature is in degrees centigrade. The temperature is changing from 20, every 2 centimeters represents 5. So 20, 25, 30, 35, 40, 45, 50, 55. So then I will plot those points, and at 0, I will plot, at 0, I will plot 20. You can see that at 0, let me bring the arrow first. At 0, we will have 21.5. At 60, we will have 27.5. At 120, I will have 32. At 180, I will 37. And at 240, I will have 41.5. At 300, I will have 45.5. And at 360, I will have 48.5. I was reading these values from the table 1.1, so I plotted these points here. Then we have to draw the smooth curve of the best fit. I have drawn this graph, this curve of the best fit with the help of the paint. So my hand is a little shaky, but you can, when you will draw this with the pencil on a paper, the curve will be very smooth. Okay, so this is how you will draw the curve of the best fit, smooth curve of the best fit. Okay, then their question, the next question they are asking is a 2-mark question. He says, use your graph to calculate the temperature rise delta theta of the water in the first 200 seconds of the heating. So at the time 0, you can see that temperature is 41. And when the time is 200, the temperature is something like, it's like 38. So 38 minus 21, that will be 17. So the rise in the temperature is, 17. Okay, now we are moving to the next part. That's question number 1, and it's D part. He says, calculate the thermal energy E supplied by the heater in the first 200 seconds and give the unit. Use the equation given. So E is equals to V multiply I multiply T. We know that the voltage was 14.8. The I was 4 ampere. The time is 200 seconds. So the electric energy used by the heater is, I will multiply these and it will give me 11840. So 11840 joule is the energy supplied by the electric heater. Then the D second part is, he says, calculate a value for the specific heat capacity of water. C, it's represented with the C of water. Use the mass given at the start of this question, your answer in the C second part and the D first part, and the equation. You know the E is equals to mc delta theta. The E is 11840. The mass at the start of the question, he said 100 grams. The small c, I want to find out, that's the specific heat capacity. Change in the temperature is 17. So the C will be equals to 11840 divided by 100 divided by 17. And you will get the answer 6.96. So 6.96 joules per gram per degree centigrade. is the specific heat capacity. Okay. Now the E part is, he says the specific heat capacity of water is 4.2 joules per gram per degree centigrade. Examine the apparatus setup shown in the figure 1.1. Suggest one practical reasons why your calculated value of the C is inaccurate. Our value is 6.9, but they say that the specific heat capacity of the water is only 4.2 joules per gram per degree centigrade. So our answer is higher, and our answer is larger. The specific heat capacity we calculated is larger than the actual value. The reason is because that apparatus, if you look at that apparatus don't have a lid on it. So when you are heating, so the rate of evaporation will become faster, and when the rate of evaporation will go faster, the heat loss from the surface of the water will also be larger. So that is the reason for our larger answer. So heat is lost to the surroundings due to the evaporation. Okay, the question was just one practical reason why your calculated value of the C is inaccurate, because we have not put lid on that water beaker. So by the process of evaporation, a lot of heat is being lost to the surrounding instead of going to the water. So state one improvement to the apparatus that produces a more accurate result. He said our answer is that we should put a lid on the beaker. So that's the question. Okay, so on the F part is, he says another student repeats the experiment and forgets to switch off the heater at the end of the experiment. The temperature of the water continues to rise until it reaches 82 degrees centigrade, and then remains constant all at this value. Suggests one reason why the temperature of the water stops increasing when it reaches 82 degrees centigrade. When the temperature becomes 82 degrees centigrade, the temperature of the water no more further rises. The reason is that the heat which you are giving to the water and the heat which is lost from the water, both the rates have become equal to each other. So that's why the temperature of the water is no more rising. So the answer which I wrote is rate of heat loss has become equal to the rate of heat gain. So this was the question number 1. I hope that you have understood. So let's have a look at the marking scheme, and here we go. So here we have May, June 2019 for 2 paper. So whole of the question number 1, its marking scheme is showing up on your screen. What you can do is that stop the video or pause the video and take your time with the marking scheme. It is very, very important for every student who is attempting this paper to read the marking scheme. So you can pause the video and you can have a good look at the marking scheme. So I'm going to the next question. The next question coming up on your screen is, so these are the questions. Question 1 is done. Okay, now we are going to the next question. That is question number 2. A student uses a ray box to investigate the refraction of a ray of the blue light as it passes through a glass prism. He sets up the apparatus as shown in the figure 2.1 and a piece of paper. So they have put that prism on a piece of paper, and they have also marked its boundary. You can say here blue light is coming, striking with the surface, this face, and it will enter into the prism. So this is the angle of incidence. He says measure the angle of incidence I of the ray on the prism at the point X. So we have to measure the angle of incidence. So I will put the protector here and I will try to measure the angle of incidence. Let me show you my answers. Okay. So here we go. So you can see this is how you will use your protector. The crosshair of the protector is at this point of incidence, and my one side is the 0 of this protector has been aligned with this normal, and you can see that the angle between them is 10 and 20 and 30. So the angle of incidence is 30. The angle of incidence is 30 degrees. And then they say the angle of incidence is 30, so we will fill that place. Then in the B part, he says the angle of refraction at the X is 70. Let me go to the question so you look at it. Okay, so this is 30 degrees centigrade. He says the angle of refraction at the X is 19. On the figure 9.2, draw the refracted ray inside the prism. Okay, mark the letter Y, the point where the refracted ray emerges from the prism. Draw the normal at the point Y. So these are the two questions. So let me show you my solutions. So here we go. So you can see I have put a protector here. So let me show you. I have put the protector like this. Okay. So I will put the protector like this. The crosshairs are at the point of incidence. This 0 has been on that normal. And then I will count 10, 20, and 19 will be here. So I put a dot on the paper. So I will join this with this point. Okay. So you can see here, I have joined these 2 points. So this will be the refracted ray. And here we go. Then you have to draw a normal at the point Y. When the refracted ray touched that the other face, we have named that point as Y. And this is how you will draw the normal on there. The crosshairs are on the point Y, and both the zeros are on the face on these sides of the prism. And I put the dot here, so that will show the normal. So you can see I have drawn the normal here. Okay. Then his question is draw the normal. Okay, we are done with that part. Okay. Then the next question is the ray emerges from the prism at Y. Describe how the student can mark the path of the emergent ray accurately on the paper. Okay. So this is the emergent ray will be here somewhere. So on that emergent ray, because the emergent ray will be visible to you, you can put a pin here and then a pin here, at least 5 centimeters apart. And you can mark their position with the help of the pencil. So where you have put the the pins on the paper, put a small circles around them, and then remove the pins and then join the line, joining both the marks until you reach the point Y. So let me show you my answers. Okay. He put 2 pins on emergent ray and marked the position of these pins on paper. Then remove the pins and join the mark with the point Y with a straight line. So this was question number 2. It was totally of 4 marks. And let me show you the marking scheme. And here we go. So now you can see the question number 2 and its marking scheme is showing up. And what you can do is you can pause the video and you can take your time with this marking scheme. To read the marking scheme, to compare the marking scheme with your answers, it is very, very important. So pause the video and have a good look at the marking scheme of the question number 2. Okay, so now we are moving to the next question, and we are done with the question number 2. Here we go. Here we have question number 3 is coming up on your screen. He says that he's saying that a student investigates the maximum height h to which a ball bounces after hitting a laboratory bench. She sets up her apparatus as shown in the figure 3.1. So here she will drop the ball and this ball will bounce, and she will note down that to what height this ball reaches after the bounce. Okay. So, okay, so this is how he will drop it. From here it will bounce, and we will check what is the height of the bounce. So let's go to the next question. He says that she drops the ball from a height of 80 centimeters above the bench as shown in the figure 3.1. After one bounce, the ball reaches a maximum height of h of 55 centimeters. So after the bounce, in the first bounce, the ball reaches only 55 centimeters, while it was dropped from 80 centimeters. Okay, so after the bounce, it will gain a height of 55 centimeter. On the figure 3.1, draw and the label and draw the ball when the h is 55 centimeters. So here, so I can show you. So here I will draw a ball. 55 is here. 55 is here, this point. So I will draw a ball here. Its bottom should be coinciding with the 55 mark. Okay, so let me show you. He says, then he says on the figure 3.1, draw the position of the student's eye placed correctly to view the ball at a height of 55 centimeters. It's a 2-mark question totally. So let me show you. So you can see here I have made that ball. So you can see this is at a height of 55. The bottom of the ball is at the height of 55. And this is the eye of the observer. So it's a 2-mark question. Then his question is B part. He says she repeats this procedure 3 more times and obtains the following results for age. So she got 54 centimeter, 57 centimeter, 53 centimeter. Use all her results to find the mean value of the maximum height age reached. Give your answer to an appropriate number of significant figure. So I will add these 3 values, and whatever the answer I will get, I will divide it with the 3. So let me show you. So you can see here. So we will have 54 plus 57 plus 53 that and divide equals 2 and divided by 3 equals 2. So that will be 54.67. So I will round it off to the nearest centimeter. So it will be 55 centimeter. And the second question, B, second part will be, the student uses a meter rule graduated in millimeters. Suggest why her results are not recorded to the nearest millimeter, because he's trying to measure the height of the bounce of the ball. The bounce of the ball is continuously moving, and for a very short time the ball stops at its maximum height of the bounce, and the ball is moving very quickly. Okay, so that's why it's very difficult to measure the height accurately in millimeters, because the ball is moving, it's not near the meter rule, it's a little away from the meter rule, and the ball is moving quickly, and there is a gap between the meter rule and the ball. So my answer is that ball momentarily stops at the maximum height and moves quickly. So that's the reason it's not possible to measure it accurately. The height of that ball accurately cannot be measured up to millimeters. The C part is the student repeats the procedure, but now drops the ball from a height of 10 centimeter. Suggests why she now finds the maximum height reached difficult to measure. If you will drop the ball from a height of 10 centimeter, that height is very small. So it will be very difficult for an observer to go down, lie down on the floor, put his head on the floor and observe the height of the bounce. So because 10 centimeters is very short height, so it's not a good idea. So my answer is difficult to measure the height of bounce, because to get head down to take reading is difficult. So you have to go down. You have to lie down on the ground to observe a ball who has been to observe the height of the bounce of a ball who has been dropped from a height of 10 centimeter. Okay, so it will be difficult to measure the height of the bounce, because to get head down to take reading is difficult. So this was the question number 3, and it was of 6 marks. So let us take the marking scheme. Question number 3 is coming up on your screen. And what you can do, my dear students, that you can stop the video or you can pause the video and take your time with this marking scheme. To read the marking scheme is very, very important. It's very important for everybody who is working on the paper. They should compare their answers with the marking scheme. So the question number 3 marking scheme is showing up. You can pause the video and take your time with this marking scheme. So Okay, so let's move to the next question. And the next question will be question number 4. He says, okay, let's put down very big. A box contains an unknown electrical component. This component is connected to two terminals P and Q on the outside of the box. A battery, an ammeter, a switch, a lamp, and two crocodile clips are connected as shown in the circuit diagram figure 4.1. So here we have the crocodile clips, here we have the connecting wires, here we have connected a battery and a switch and an ammeter and a lamp. So I will connect these two here. So the lamp and this whatever here we have, they will be in series with each other. So his question is, the unknown components are either a broken wire or a connecting wire or a diode. Describe how to use the apparatus to determine whether the component in the box is a broken wire. If the wire will be broken when you will connect the crocodile clips with the point P and the point Q, the lamp will not lit. If you reverse the battery, even then the lamp will not lit. So that will show that you have the broken wire. Then he says the connecting wire. So when you connect the connecting wire there, so the lamp will lit, and if you will reverse the battery, the lamp will still lit. Then he says a diode, if you have put a diode, you know that diode will let only the current flow in one direction. So in the one orientation of the battery, the diode may be in the forward biased and it will let the current flow, so the lamp will be lit. And when you will reverse the battery, the diode's arrow and the direction of the conventional current will be opposite. So the diode will not let the current flow through it. So the lamp will be not lit, it will be off. So that can show that in one direction of the battery, the current can flow, the lamp is lit. And when you reverse the direction of the battery, the lamp do not lit. That will show that you have a diode there. Okay, because the diode, you know, the diode let the current flow only in one direction. If the current will try to flow in the opposite direction to the arrow of the diode, and the diode resistance will become very high and it will not let the current flow through it. Then in the B part, we have here we have the components in the box is a low resistance connecting wire. A second box looks identical but contains a higher resistance resistor. Describe how to use the apparatus to determine which box contains the resistor. You see, when you will connect the PQ a resistance, a low resistance connecting wires, the lamp will be bright as normal. But when you put there a second box and who has a higher resistor in it, so because the lamp and that resistors, they will be connected in series with each other. So the brightness of the lamp will be affected and the lamp will be not that much bright. So that is question number 4, and we have reached the end of the paper. So let me show you my answers and then we can for the question number 4. Okay, so for the question number 4 on your screen, my answers are coming up. So their first question was, describe how to use the apparatus to determine whether the component in the box is a broken wire. Lamp will not lit even when battery is reversed. Okay, so a connecting wire lamp will lit when battery is reversed, it will lit. So it will lit, and when you reverse the battery, it still will lit. So if there is a diode, the lamp will lit with one orientation of the battery. When you will make the second other orientation of the battery, the diode will not let the current flow through it, so the lamp will be switched off. So okay, so the next part is the components in the box is a low resistance connecting wire. A second box looks identical but contains a higher resistance resistor. Describe how to use the apparatus to determine which box contains the resistor. So with the box which has resistor, lamp will lit, but it will be dimmer. So when you connect a box which has a high resistance in it, so what will happen? The lamp will become dimmer because the lamp and that high resistance will be connected in series with each other. So the lamp will become dim. So this was the question number 4, and that was the last question. So my dear students, hopefully you understand this paper. And today we have reached the end of this paper. Today we have done May-June 2019 Physics 5054 Fold 2 paper. This is Cambridge O-Levels Physics 5054. We have done today the ATP paper. We call it paper 4. This paper was from the zone 2. If, my dear students, you find this video helpful to you, if you find that this video is helping you to solve the ATP paper, and you are able to understand the ATP paper, and if you think that's been beneficial for you, don't forget to subscribe to my YouTube channel and share the link of this video with your friends, with your class fellows, with your senior students, with your junior students, by posting the link of this video on the Instagram and the Facebook. So it was a great pleasure teaching you all. So thank you very much, my dear students, and have a good day, and God bless you all.